Hey there guys, we've been working a whole lot recently on graphing circular functions, and we're finally at the final video where you're actually going to be asked to graph. I will show you some others where you're given a graph and asked to write an equation for a circular function. But again, last one where we're actually going to have to graph. And you can see that we're going to be graphing some complicated looking functions. Y equals a sine of b times the difference of x and c plus d, and in the same equation but with cosine instead. Now, all this complicated equation is a sine equation or a cosine equation that has vertical stretching, has horizontal stretching, has horizontal translations, and it has vertical translations. In other words, where we've been looking at each of these different types of transformations separately in the past several videos, now we're going to throw them all together where you can have an equation that has all of those types of transformations and reflections as well in horizontal lines. Alright, so we're going to actually make two graphs here, one sine and one cosine within this video. And here's the sine function that we're going to graph, and you can see that it's got a vertical stretch, a horizontal stretch, it's got a horizontal translation, and a vertical translation. All of those things. And it's got a reflection as well because our a is negative. Now the directions here are a little bit different than what we've been doing with graphing. We've only been graphing these trig functions on the interval from negative 2 pi to positive 2 pi every time. This time it just says in the directions to sketch the function over at least one full cycle. Now maybe that full cycle just goes from negative pi to positive pi. Maybe it goes from 0 to 3 pi. But we have to be able to sketch at least one full cycle. Sometimes it makes sense to sketch more. We'll see what we come up with as we graph this sine function that we're going to work with. Alright, now let me talk about my philosophy whenever I'm going through and trying to graph one of these sine functions. The thing I care about figuring out first is how high and low the graph is going to go. So, there are two things that are going to affect how high or low the graph is going to go. One of those is going to be the amplitude of the function, right? And we know that this value a, its absolute value is the amplitude. That's going to be a pretty important consideration. The amplitude is going to be 7/2. I'll go ahead and write that here, or 3.5. And that tells me that the graph will vary by 3.5 units above and below its middle value. All right, well, so that's a relative term. We've got to know where the middle value is. And so the other thing I care about right now in terms of how high and low this graph is going to go is I care about the vertical translation, this -2 at the end. That tells me that we're going to have a shift of down 2 units. Alright, so very important. Now what I actually like to do is put a little dotted line where, oh I forgot to put the 2 there, where the middle value is going to be. So let's go ahead and go to y equals -2 and place that line. All our intercepts, or our middle values, so to speak, will lie on that line. Okay? Now, here's the next thing I want to discuss. I want to make sure I know what pattern it is I'm going to be running through. Alright, now I drew this circle here just to remind you of the pattern for a sine function. These are the sine, this is the sine of 0, the sine of pi over 2, the sine of pi, and the sine of 3 pi over 2 that I've written in right there. Remember that the sine value always starts at its middle value, and then a quarter of the way through a cycle works its way up to its maximum. Halfway through the cycle, it's at the middle, the middle again, and then the minimum 3/4 of the way through, and after 4/4 of the way through the cycle, it gets back to its middle value, right? However, that is going to change a little bit here because of this reflection thing. The fact that a is negative tells me I've got a reflection, and that actually tells me to reverse the cycle rather than going positively around the circle, so to speak. What we're going to do is go negatively around the circle. And so my pattern is I'm still going to start with a middle value, but 1/4 of the way through the cycle I'll get to the minimum, and then the middle, and then the maximum, and middle again. So I'll write that down here at the pattern. Alright, now the other thing I need to know is where does the first value in a cycle occur? Ordinarily we would start at the y-axis, wouldn't we? But there is a reason that we wouldn't start at the y-axis here, and that's because we have a horizontal shift. Now, so we know we're going to move pi over 3 to the left, so let me go ahead and write that in my shifts. Before I go ahead and make this pi over 3 to the left, though, what I would like to do is determine what kind of intervals I wanted to use. And there's one more thing I like to consider before I decide on my intervals for my graph. Now, you've always seen me go by pi over 4, so that this is pi over 4, then pi over 2, then 3 pi over 4, pi, and so forth. But that was just made it easier when we were graphing from negative 2 pi to 2 pi. When all I'm told to do is sketch a function over one full cycle, I could actually even make it easier than that if I know the period of the function. What is the length of that one full cycle that I'm going to try to create here? So, remember, the way you determine the period is you divide, for a sine function, a cosine anyway, 2 pi by the absolute value of b. So we would have 2 pi divided by 3, and that's it. We can't simplify that anymore, so that's going to be the length of the period. Now listen very carefully to this next part that I'm going to tell you, because it truly makes graphing a trig function easier, but you've got to understand the logic that goes into it. When I'm deciding what my intervals are going to be, I use the fact that we can divide up a full cycle of sine or cosine values into quarters. We can talk about 1/4 of the way, half of the way, 3/4 of the way, and all the way. And the way I take advantage of that is I simply, to determine my intervals, divide the length of one cycle, the period, by 4, or I multiply by 1/4. So for my intervals on the x-axis, we're going to find 1/4 of our period. All right, that becomes 2 pi over 12, or pi over 6. And what I'll do then is just make each individual grid line horizontally be worth pi over 6. Now, I like to label every other grid line. So rather than labeling this one as pi over 6, I'm going to label this one as 2 pi over 6, which is really pi over 3. Correct? And so then here would be 2 pi over 3. And the advantage to that method is that I've made one full cycle over 4 grid lines. And every time you just divide your period by 4, you're always going to complete a cycle within 4 grid lines like that. And it makes it much easier, a much more repeatable thing to do whenever you're graphing these functions. Okay, so I can fit one full cycle between here and there. I'm going to go ahead and label some more of the intervals here. That would make this pi, 4 pi over 3, and so forth. I'll just fill out my graph. And then do the same thing on the negative side of the x-axis. Now, I already determined my intervals on my vertical axis while I'm thinking about intervals. I just didn't label it, but the fact that I didn't label it already implied I was going by ones, but I'll make it official right there. So that's 2, and this is negative 2 right there. All right, so here's the last little bit of it. I found the period so I could determine my intervals already, and that way, now I can take advantage of the fact that I know this thing is going to shift left pi over 3 units to begin actually plotting the 5 points that belong in a single cycle. Remember, we want to start with the middle value, and what we can do is we can start that middle value at negative pi over 3, because we're shifting from 0 to negative pi over 3 for our starting value. So let's put a middle value there, and remember, the middle values go on this horizontal line that we drew, because the middle value of this function is going to be negative 2 due to the vertical translation. All right, and then I'm going to go to the right to begin here. As I go to the right, I'm going to go from a middle value to a minimum value next. Now, that means as I go 1/4 of the way through the cycle, and remember, each grid line is 1/4 of the way through the cycle, I'm going to get to the next value right here, the minimum value. And since the amplitude is 3.5, that means negative 5.5. Okay, negative 2 and then 3.5 below that. Negative 5.5 is where this minimum value is going to go. Right there. Then the next grid line over signifies that we've gone halfway through our cycle, and that's going to be a middle value again, and then we'll go for a maximum value. If you go 3.5 above our middle value of 2, you're going to get to 1.5, and then we've completed the cycle once we get back to pi over 3. Whoops, that's in the wrong place. Let's put it on our middle value right there, and let me draw in that cycle. Now I want to make sure you see a couple things. You can tell that you've gone through a cycle whenever you've gone from the middle value and then you've gone all the way to the minimum and maximum and back to a middle value again. All right, as long as you've gone through a minimum and a maximum, you've gone through the whole cycle. And we can tell that that cycle was the correct distance because what is pi over 3 minus negative pi over 3? Well, it's 2 pi over 3, right? So we can tell the length of that cycle was 2 pi over 3. That's what it was supposed to be according to our period, correct? Now, the instructions said to graph at least one cycle. I'm going to graph one more cycle to either side, but this will be sufficient for this problem. So now I'm just going to continue that pattern. Every one grid line, being 1/4 of my interval, is going to, continue the pattern. So I'll go to minimum value, mid, max, min, and so forth. Let's just go ahead and do that to both sides. All right, so there's one more cycle going off to the left, and I went ahead and drew a little bit extra, put an arrow there just to signify that it continues. And let's do the same thing on the left side. There we go. Okay, so that's how you graph a trig function, a sine or a cosine in particular, that has all the different types of transformations within it. We're going to do one more. We're going to do a cosine function as I alluded to earlier, or maybe didn't allude, I just said it flat out. Here is that cosine function that we're going to be graphing. And we're going to go through all the same considerations here that we did before. We're going to start with kind of the vertical consideration, how high and low is the graph going to be. And we can look at our amplitude, and we can look at our vertical shift in order to kind of get a feel for how high and low the graph is going to go. We've got a shift of 1 unit down, and I'll do the same thing I did before where I put a little dotted line through y equals -1 here, so we know where our center or our middle value is. There you go. And then the amplitude is going to be 1/2. So our graph is going to fluctuate as far as its y values between -1/2 and -1.5. It's going to go half a unit above that middle line, and it's going to go half a unit below that middle line during the course of a cycle. Okay, now we need to think about horizontally where is this graph going to be, and I'll start with what's the pattern going to be as well. Where the cosine, typically, remember, you start at the maximum value, then mid 1/4 of the way through, min half the way through, mid 1/4 of the way, 3/4 of the way through, and then you're back to your maximum once you get all the way through. And since our A is positive, that's not going to change. It's exactly what we're going to do. We're going to start at a maximum and then go around the same way that we were before. If it was negative, of course, we would have started at a minimum value instead of a maximum value. Here's the pattern. Next, let's go ahead and consider what the period is so that we can determine what our intervals are going to be. And our period will be determined by that horizontal stretch, what the value of b is. And again, we're going to do 2 pi divided by b in order to calculate that. So if you have 2 pi divided by 1/3, well, that's the same thing as 6 pi, isn't it? Okay, and if my period is 6 pi, I'm going to go ahead and divide that by 4 to determine what my intervals on my graph are going to be. And that's going to be 1.5 pi or 3/2 pi. So let's go ahead and start labeling those. Now, if this is going to be 3 pi over 2, then this is going to be 6 pi over 2 or 3 pi. And so then we'll have 6 pi and 9 pi and so forth. Great. Only one more thing to consider here before I actually start graphing. If I'm going to start at the maximum value, I've got to know where I'm starting. And since we have a horizontal shift, it's not going to be right there, is it? Okay? So we need to shift this by pi units to the right. So let's think about where pi would be. If this is 3 pi, then that would be 1.5 pi. Let's say 1 pi is right around here. And this is where I'm going to begin. And I'm going to begin it with a maximum value at x equals pi. So let's go ahead and do that. The maximum value will be a half unit above our little central value right there, right? All right, and now because of the clever way that we chose our intervals, all we have to do is figure out from here, when have we gone 1/4 of a way through our cycle, and halfway, and 3/4 of the way, and every one grid line will represent 1/4 of the way through your cycle. So here is 1/4 of the way through the cycle. We want that to be a middle value. Then this would be 3/4 of the way through the cycle. And this would be, well, that's halfway through the cycle, excuse me. This will be 3/4 of the way through the cycle. And we'll have completed the entire cycle by the time we get to right there. And just want to show you that we've done this correctly so far according to the measurements that we made with the different values in the equation. You can see that we started at 1 pi, and then what we ended up doing was ending at 7 pi because we added 1.5 here, gave us 2.5 pi, then another 1.5 gave us 4, another 1.5 pi gave us 5.5 pi, and then another 1.5 gave us 7 pi. All right, and that means that we did indeed have a period of 6 pi units, which is exactly what we're going for. All right, now there is our one cycle. I'm just going to continue one cycle to the right and the left. I just prefer to do it that way unless it doesn't fit on the graph, and it clearly does here. So here's another 1/4 of the way. Here's half the way through the next cycle, 3/4 of the way through the next cycle, and finish with the next cycle. So there's one more cycle to the right. And again, I'll kind of leave that little arrow signifying that we're going to the right more. Now notice we're not anywhere close to fitting between negative 2 pi and 2 pi here. We're already out at maybe 12 pi or something by the time we get to right there. And let me also spread this out to the left. So if I'm going back, one grid line over would be around right there. That's my 1/4 of the way. Here's my halfway, 3/4 of the way, and all the way through the cycle. So there's 3 cycles of this cosine function. Hopefully that's made graphing these big old sine and cosine functions a little less intimidating for you, because I think I've given you a method that you can repeat with a good deal of accuracy. All right, appreciate your attention. Good luck with this. See you later.